Hi, Mr. Hess.
This
Welcome to discussion of congruent triangles, congruent figures. In general, discussion of congruence. We're going to focus on triangles. We're going to focus on triangles pretty soon here. So you've got a bunch of images on your paper that appear, might look like they're somewhat congruent on there. For example, Aria, are those two dogs congruent to one another? Mm-hmm. Congruent means the same. Yeah.
No, they're not the same.
Why not, Aria?
Because this one is brown and this one is white.
Color is not an identifying quality of congruence. Good try. Give me a different reason.
Because both of his ears are pulled back and one ear is down.
Okay, so the angle of the ears changes. That would make them not congruent. Well done, Aria. Or the shape, one's a little more round than the other one. How about the shamrocks? Sorry, we just had what holiday? Not Corona Day. St. Patrick's Day.
St. Patrick's.
Are these two shamrocks congruent?
No.
No, actually they are. One is just turned, 90-degree rotation over the other. So if things are rotated, they can still be congruent. You got that one wrong. That's okay. You got 1 out of 1. One out of 2.
This one is straight and this one is...
It just turned, young lady. It just turned. And of course, over here, you got Mini-Me and Dr. Evil. Maybe a scaled model of one another. Of course, they're not congruent. How about the little triangles?
They are the same.
Yeah, they're congruent. They're just a reflection of one another. And the next unit, chapter 8, actually, we're going to talk about why they're congruent, the transformation that maps them. So, like, this is a rotation. This is a reflection. How about the strawberries?
They actually are the same.
All of them? All 3 of them?
Mm-hmm.
It appears that they've been sliced. Students like to argue about this one. I think those 2 are probably congruent. We're not sure about that one. How about the pentagons?
The pentagons, yes, they are the same.
She's wrong on that one, too. You can tell she's a math teacher's daughter. Why are they not the same? What's different about them?
This one's small and this one's bigger.
Bingo, right from a kindergartner. One's bigger, one's smaller. So they can be the same shape, but they also have to be the exact same
height,
size, exactly. Bingo. How about the L's here, these little L shapes? Congruent or not?
They're the same.
Bingo. This one has been rotated. It looks like this one's been reflected. If you look carefully at those actually are congruent on there. So a quick little refresher of the definition of congruence on the bottom of this slide. Figures are congruent. So 2 shapes are congruent if they have exactly the same size and shape. That's 2 things we're looking for. So, which means the side lengths are the same and the angles have to be the same. Yeah. Both of those. They also have to have...
We don't know about that one because this height is fatter and this is...
We could measure it with a compass, though, right? We can measure with a compass, right? Bingo. And this little thing, I think it's on your paper. Size implies the angles are the same. Sorry. Size implies the sides are congruent or equal. And shape implies the angles are equal. You could write on there. We'd rather... There it is right there. We got it. Okay? Next deal. So one of the things we want to... All right, can you be quiet for a second? One of the things we want to focus on in this section is letter order. So I'm going to throw in some words on here about congruent triangles on here. Every pair of... Can you stop for a second? Every pair of sides and angles have to have a corresponding part. And we use the word corresponding. We talk about parallel lines. This is just another application of the word corresponding. And it's an important application of it. It's going to come up later on. So they have to have a corresponding part that's congruent.
This is what it looks like.
So on your paper, I didn't give you the sets of sides. Obviously, there's 3 sets of sides and 3 sets of angles. This one, I want you to actually use the scale of the drawing to figure it out. This is called a translation. I just took one triangle and slid it down to the other one.
Yep.
So angle D should be congruent to which angle here? Angle C. So take a minute, pause the video. Should be able to come up with 3 pairs of congruent or corresponding angles. And if I was in class, you'd hear me say the word corresponding. Excuse me. You'd hear me say the word corresponding about 6 times on there. And again, letter order matters. So I want to do this in a proper letter order. But again, this is the time to pause, complete those 6 statements, try to match up corresponding parts and that are congruent. Now, you'll notice my letter order here. I'm trying to be consistent with my letter order. It's not super big deal with segments. If I call this AC instead of CA, that'd be okay. If I call this one TC instead of Connecticut, that'd be okay. But if you start to pay attention to those details now, it makes it easier when you're naming triangles or angles where it does matter about the letter order, which is what that next question's asking you about. There's 3 sets of congruent triangles named on there, but they're not all correct. In other words, the letter order is so critical that we want the letter order to tell us which parts are congruent. So if you look at those, one of those 3 is correct.
And which one is it?
You can tell this one's not correct. Let's use black instead. Because D does not correspond to T. You can tell this one is correct because each of those parts match up properly to its corresponding part. And the same thing on this one. To make this one correct, I have to switch around either these 2 or switch around those 2. So when we're naming congruent triangles later on, doing proofs, there is a proper order on there to naming those. Every part should match up properly. Now, I don't think you know what the word isometric means because we haven't talked about that yet. But typically, can you get off there? Typically, isometric means iso, same, and metric means measure. So which type of isometric transformation? So I mentioned it a minute ago. It's called a translation when you slide it down. We're going to be doing a lot with translations later on. I mentioned a reflection and a rotation earlier. You're going to see those terms come up quite a bit. So I'm sort of previewing something that's going to show up later on in this discussion. This one I want you to try on your own. Don't think it's necessarily drawn to scale. I need you to use the marks that are given on here just to set up some congruence on here. So BO and IN are congruent. Maybe that's not the best letter order. Those 2 are congruent. And then these 2 are congruent. This is one where it's more of a discussion in class. Probably not the most beneficial thing because it's a lot like the previous one. But I do want you to be thinking about the type of transformation that gets you from one to another. Because when I started this, you probably looked at this and said, oh, it's just a reflection. Once I give you these marks, you know it's not a reflection. There's something else going on there. It's not just being flipped over. It's being turned or rotated. And if I was in class, I'd ask you, how many degrees is being rotated? So think about that for a minute. You might realize it's being turned all the way around 180 degrees around some point in the middle. So I'd also ask people to figure out which angles correspond. So like, what does angle R correspond to? Put some marks on the drawing to show that. You'd see that R corresponds to W. What does angle B correspond to? B corresponds to N. And you'd add some marks on there like that. And then identify those parts just means, match up all your sides and all your angles. Angle B corresponds to angle N. You can see that O corresponds to I. And the same thing with side lengths. And again, I'm going to care about letter order here. If I say row, and I'm going row that way, I want to go WI that way, just to try to get used to caring about letter order. If I say BR, I'm going from B to R. If I rotated that, now B is on N, I'd want to say NW instead of WN. Not wrong to call this WN, but a little better to call it NW. And of course, there's your last one. And the last thing I have for you is this thing called, I got a triangle statement on there. Finish that statement. Triangle win is similar to or congruent to the other triangle. Try to get your correct letter order. I'll be back again here in part 2 in just a moment.